All right, are you hearing me now? Sorry about that.
Yes, sir.
All right, thanks for your patience. All right, so what we are going to be looking at now is just to ensure that you're able to represent glycolysis in a flow chart. So when you're studying, use a flow chart to represent it. All right, so it's not much. It's just to understand the aim. What's the aim of glycolysis, where this process takes place in the cytosol, in the cytoplasm. Yes, Banton, go ahead. Instead of bisphosphate?
Yes, sir. I'm keeping phosphate, sir.
Yes. Books will have it. It means it's just that it would have underwent 2 phosphorylation, so they're acceptable. Don't worry about it. Glycerate phosphate. Those intermediates. Sugars. So in some books you may not even see GP, you may see intermediates, which is saying that before pyruvate can be formed, then it must be broken down to release 2 ATP, to bring it down to 2 pyruvic acid. So that's not any big deal. Just for you to understand or be aware of the different things that may be included, so that you don't, you're thrown off because of 1 or 2 changes. All right. So the first thing, as I made mention, if you're looking at the process of glycolysis, and a question was shared in the workshop where it asks you to think an overview of glycolysis. There are about 7 or 8 marks. So what you would have to do is just give like a definition for glycolysis, that it is the process by which glucose is broken down into a smaller unit, and then you may want to put in bracket 2 3-carbon sugars, 2 pyruvic acids, and this is to ensure that it is able to enter that of the mitochondria. You may want to state, the products, other products of that in terms of the net production of 2 ATP and 2 reduced NAD, and then you introduce that the flow chart below summarizes the process. And you start off with your glucose, and the glucose will undergo 2 rounds of phosphorylation. So 2 ATP will be invested in it, and that's what you call the investment phase of it. So if you notice, the addition of an ATP will result in the glucose now being glucose phosphate. All right, so right there we see that is the first phosphorylation. Then, so let me start to outline the processes. Let me get my annotation. So right here, all right, so right here we have 1 phosphorylation, all right, to give us glucose phosphate. So this process is called phosphorylation. All right. Then, if you notice, glucose is reshuffled by enzyme to form fructose. Isomerization takes place here. Isomerization. So we have to identify the processes: phosphorylation, isomerization. And then we have another phosphorylation to form the bisphosphate component. So right here, we have to be able to identify the different processes. So first thing, glucose is phosphorylated to form glucose phosphate. All right. Then it is rearranged to give us fructose phosphate. Then it undergoes another phosphorylation to give us fructose bisphosphate. So we end up having 2 phosphorylation and 1 isomerization in that investment phase. So the whole part here, we want to categorize it that the entire region here speak to the investment phase of glycolysis, because we would have invested 2 ATP to facilitate the 2 phosphorylation here. And what we notice also that happened here is that glucose is rearranged to form fructose. All right. So those are the events that you would summarize in the investment phase. All right. So you will get like 3 marks right here just to outline this process. And then we move back to the payback phase in glycolysis, where that fructose bisphosphate is broken down into 2 triose phosphate, which is 2 3-carbon sugars. And then you have the oxidation. So you have oxidation of triose phosphate that will produce 2 ATP and 2 hydrogen. And those 2 hydrogen will be picked up by the NAD to form 2 reduced NAD. So the oxidation of the 2 triose phosphate will produce 2 ATP and 2 protons will be given up. Those 2 protons, remember they are high energy. They will be picked up by the NAD and they will become reduced now. So there are 2 reduced NAD and 2 ATP that are produced. Now, having harvested those 2 ATP, those 2 reduced NAD, what is left is what we call the 2 intermediates or 2 glycerate phosphate. But what happened here is that they still have some amount of energy that can be removed from them before they reach that of pyruvic acid. So what happened there? They will be further broken down to harvest that of 2 ATP, so 1 from each. So right there we end up again harvesting 2 ATP from the intermediate, and what is left now is the pyruvic acid or the pyruvate. So in all, you would see us adding up right here. Where's the annotation? All right, so right there we could add up. We could add up here 4 ATP, 4 ATP that is produced, 4 ATP that is produced, and 2 so from this we can add up that we produce 4 ATP and 2 NADH, or we can call it reduced NAD. All right. So the question at times they ask you for the net production. So having done this, having outlined the steps of glycolysis, you would have seen the investment phase that we would have put in 2 ATP right there, And right in the payback phase, we see that we would have earned 4 ATP and 2 reduced NAD. What will happen there is that you have to make your do your subtraction so that you can represent the net production of ATP or high energy molecule. Yes, Romain?
Sir, given our analysis, sir, is it safe to use these layman terms?
Yes. Oh, payback and investment?
Yes, sir.
Yes, very safe. That's powerful. Yes. So you can say that it has an investment phase and a payback phase. Put it in inverted commas, but you're explaining that, yes. So it is safe. Some books will even represent it in other ways. So like economics, those persons that do economics and MOP, we appreciate it. So don't think that because it's biology, you have to bring your own touch to the knowledge. That's how you understand it. They can't give you wrong because it is not. We are using the same term. We are looking at glucose phosphate, but we are doing a twist to it in terms of an investment. We would have invested 2 ATP there, and we would have harvested, or in this case, we could say the payback phase. So some books will have even those terms. So don't think that they are unique to my class or what I'm saying, because even while studying, that's how we, at university, that's how we treated it. Investment, payback, harvest, planted, and so forth. So what you need to do for glycolysis when you're studying, try to break it up in the investment phase. What happened in the investment phase? 2 phosphorylation, 1 isomerization. In the payback, the oxidation of the triose phosphate, and to look at what happened by the intermediate, and to account for your 4 ATP overall production and your 2 reduced NAD. And then you said, here what? Go back up top. We see where we'd have invested. We'd have invested there about 2 of my ATP, so I need to get back my capital from it, so I'm going to take it out. So really and truly, from the process of glycolysis, we would have produced 2 pyruvic acid, 2 ATP, and not 4, because we would have invested 2, so it's 2 ATP and 2 reduced NAD. So these are what they call the high energy compounds. The reduced NAD and that of the ATP molecules. So you really want to summarize your answer by looking at the net production of glycolysis, which is stated here. Normally, when you're given a question, you don't get a question on respiration completely. You will get a question only on glycolysis, a portion there. So this question may be 7 marks, 6 marks, 8 marks. You may get a question on the Krebs cycle and not this. You may get a question not on this, not on the Krebs cycle. I'm talking on paper 2, but you get it on oxidative phosphorylation and the electron transport chain. So that's why we have to understand it in fragments, so that when we are prepared, not for respiration, we are in general, but we are prepared, by fragments. We zoom into this, so we are not rushing it. We zoom in. Tomorrow we will look at link reaction, the Krebs cycle, and then we move into oxidative phosphorylation and the electron transport chain, and then we look over into the anaerobic segment, and we also have to look at that of the respirometer. So having done that, we will move over into next week, talking more about photosynthesis. Or probably if this topic run over into next week, not a problem. We have 2 extra weeks, so we can continue to add, bits and pieces. Do not try to study everything at once. You'll throw up. You try to digest the content in fragments and you understand it better. All right? So what I want you to do, ensure that you go through this today. Tomorrow what we will do, we will pick up from here and continue. And, we'll just work with the flow. All right?
Yes, sir.
All right, so see you guys tomorrow, same time, as we pick up from here. All right, so just revisit what we would have covered today, and tomorrow we'll just build on it.
Yes, sir.
All right.
Tomorrow.
Yeah, man. Yeah, man. All the best.